All right. So here we are on page Q10. This is called rational exponents. So one thing to know is the word rational basically means fraction. Okay, that's what rational always means. When we do like rational functions, those are functions that are fractions, whatever, doesn't matter. But that's what rational means. So now we're going to be dealing with how can you rewrite square roots as exponents that are fractions. So he goes into some like wordy stuff here, but I don't feel like that's super helpful. What's super helpful is just the basic rule of this. If I have the square root of x, let me actually do one that's not square root. Let's say I have a fourth root of x to the third. The way that can be rewritten is x to the 3/4. The exponent with the x becomes the numerator, and whatever root you're taking, fourth root, third root, square root, that becomes the denominator. This is your basic rule. Everything we do today is going to build on that. So his example here of the square root of x, well, we don't see the little 2 here, but we know that there's a 2. And we don't see the little 1 with the x, but we know that there's a 1. Okay, so we know this is x to the first and it's square rooted. That can be written as x to the 1/2, okay? X to the 1/2. Now that exponent is a fraction, and it looks really scary and it is really annoying, but it's gonna be okay. This one is x to the first, but we're cube rooted. So we're x to the 1/3, x to the 1/3. So that's our first general rule that we wanna make sure we understand. So first let's look and simplify these first 8 questions. I think we should be able to probably simplify just from that one rule. Okay, so I'm going to start with, start with number 2. Maybe just give it a quick pause and then come back and make sure that you're right. How does this get rewritten? Okay, pause it and try it. Now you're back to me. So this would be 5 to the 3/4. Okay, number 3, maybe pause it and try it. This would be 4 to the 1/6. Number 4, pause it and try it. This would be 3 to the 1/5. Oops. And then number 1, that looks a little bit different. It's okay though. This 2 can really just, how do I? Yeah, same, okay. Sorry, I had to think about something. This 2, if it's written outside of parentheses, it's okay. This is the same as 2 squared to the 5th root or whatever. So this is the same as 2 to the 2/5. Okay, so that's the first part. The second part is going backwards. Now we're given the fractional exponent. Can we rewrite it? So let me do this one, and then you should try number 6. So this one's going to be x to the first, 4th rooted. In the end, I wouldn't leave the 1 there because it's just not something that we normally do in our notation. We would end it like that. Okay, this one, pause it and try it and come back. So to come back, this should be x to the 3rd square rooted. Okay, to continue, now we have more than just an x getting to the 3/5, but that's okay. So this is 3x, which should stay in parentheses to the 3rd, 5th rooted. Try number 8 and come back. Okay, so this should be 2x to the 3rd, 4th root. 4th root of 2x to the 3rd. Again, if you don't have these parentheses, it's not correct. One other way you could rewrite 7 and 8 is if I don't want the parentheses in that square root, that cube or that power of 3 goes to both of these. So it's 2 to the 3rd, which is 8, and then x to the 3rd. That would be another way you could see that problem. Number 7, if I want to get rid of the parentheses, it's 3 to the 3rd, so that's 27, and then x to the 3rd. This is probably your simplest way, but there's nothing wrong with this step or this step. Okay, now in the next few, he has you actually getting an answer. So no fractions, or the answers aren't going to, or I should say they're going to have to be simplified when you're done. So here we got 25 to the 3rd square rooted. Probably no problem, right? But this can break down. So inside this square root, I have 25 times 25 times 25. I don't want to multiply that all out, but I do want to realize I have a lot of pairs that can come out. So I can reduce this a lot like I reduced square roots in all of our previous lessons. So this is a 5 times 5 and a 5 times 5 and a 5 times 5. Pair, a pair, a pair. So how many 5s come out? 5 to the third, or 5 to the third is 125. That's my final answer. Let's try number 10. So number 10 is saying 16 to the 5th, and we're fourth rooting. So that's what we just learned, how to rewrite that exponent that's a fraction into a root. But now, can we simplify this more? So the fourth root of 16 to the 5th means 16 times 16 times 16 times 16 times 16. Now, instead of having to break every 16 down into its factors, you might also be able to skip a step. And every time I'm trying to fourth root something, I'm looking for 4 things to take out. Well, I have 4 16s. I don't have to break them down into the 2 and the 2 and the 2. You're going to have so many 2s. Why not take a shortcut and realize I just need 4 of anything that's the same to come out. So I have 4 16s. Beautiful. They're going to come out. But then I also have this 16. I don't have any more 16s, but now I am going to have to break this down. So 16 breaks down into 2 times 8, which is 2 times 4, which is 2 times 2. Oh, guess what? I do have 4 2s. They can come out and join the 16, leaving me nothing inside but a final answer of 32. Okay, I hope that makes sense. But please know, like we can video chat and just go over any questions that you have, because it is hard. Maybe if you feel like you kind of get it, I would pause this and come back to this question, unpause, and then see if you really got it. So let me go through. So this is 8 to the 5th, cube rooted. So this means I have the cube root, and I have 8 5s. Or I'm sorry, I have 5 8s. 1, 2, 3, 4, 5. Instead of breaking them down all the way, I'm going to realize, oh, cool, I've got 3 of them. They're going to come out. And then this 8 is 2 times 4, which is 2 times 2. Oh, sweet, another group of 3. And this 8 will be the same, 2 times 4, and that breaks down another group of 3. So 3 8s are coming out, 3 2s are coming out, 3 2s are coming out. Nothing's left inside, and my final answer is 32. Okay, last one on this side, we got 48 squared, cube rooted. So I've got the cube root of 48 times 48. Well, I'm looking for groups of 3, which I don't have. But I'm going to be able to get some groups. So I got 48 is 4 times 12. 12 is 4 times 3. I could go further with the 4s, but I know something special is going to happen. I know this other 48 is going to give me a 4 times 12 and a 4 times 3. So I know I'm going to get 3 4s. I don't need to go further. This is the first time I think in a video I've shown you that I don't need to go all the way down to my 2s. It just takes more time. So now hopefully you're getting the hang of this to the point where that makes sense. So I'm looking for groups of 3. So 1, 2, 3 4s. So 4 is coming out. They're canceling.
Attention student staff, this is Mr. Mayor. At this time, we'll be conducting our security drill. It will be a lockdown drill. Thank you.
All right, hold on. Now I need groups of 3, and I have no more triples. I've got a 3 and a 3 staying inside. This 4 breaks down to 2 times 2, but that's no triples. Hold on, I gotta close the door. Okay, I think I'm supposed to stay out of sight. Hopefully I am. Sorry about the noise. Of course.
Lockdown.
My final answer?
Lockdown. This is a lockdown emergency. Please enter into lockdown mode. Move quickly to a secure location and follow our lockdown procedures.
My final answer is 4 on the outside.
Lockdown. 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 This is a lockdown emergency. Please enter into lockdown mode.
36 on the
Move quickly to a
inside.
secure location and follow our
Sorry, I'm
lockdown
going to be quiet for a
procedures.
minute till this is done.
Lockdown. 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 This is a lockdown emergency. Please Please enter into lockdown mode. Move quickly to a secure location and follow our lockdown procedures.
I'll have the picture come back into view when I start again. Sorry, it's taking so long. Okay, this is taking a really long time, sorry.
Attention student staff, this is Mr. Mayor. At this time, our lockdown drill is over. I repeat, our lockdown drill is over.
Okay, there we go. Sorry about that. Okay, here we are back. Okay, so now we got a little bit more rewrite in radical form, then reduce. So now we're kind of putting everything together that we just did.
Attention. The
Oh,
emergency condition has been
so
cleared.
frustrating.
Please resume normal activities.
And we're going to throw variables into the mix in terms of the
Attention.
reducing.
The emergency condition has been cleared. Please resume normal activities.
So when I see that exponent that's a fraction, I'm going to immediately rewrite this. So this is x to the 6th, and I'm fifth rooting. Then I'm going to see if I can break this down anymore. Well, yeah, I've got x to the 6th. So this means x times x times x times x times x. 1, 2, 3, 4, 5, 6. Well, all I need is groupings of 5. So 5 of those x's are going to come out. One of those x's has to stay in, and that's my reduced answer. All right, number 14. Keep in mind, this exponent only goes to b. It does not go to the 2. So no matter what, 2 is not going to be in a root. So I'm going to have 2, and then I'm going to have b to the 5th square rooted. Now I see, can I reduce any more? So 5 b's, 1, 2, 3, 4, 5. I need pairs to bring out. Notice I didn't write the 2 in here because it's a square root. We assume when there's no number, it's square root. Partnered up, no partner. So on the outside, I'm going to have a 2 and a b and a b. On the inside, I'm going to have the one lonely b with no partner. I end up with 2b squared root b. That is reduced. Okay, 15. But the parentheses means this whole thing is being affected by the exponent, whereas in the other one, just the b was being affected by the exponent. So that means I've got 27x all raised to the 7th, and I'm cube rooting. So that literally means cube root, I've got 7 27s and 7 x's. I'm going to put my group my numbers together. 1, 2, 3, 4, 5, 6, 7. And I'm just running out of room, so I'm going to then group my x's underneath. 1, 2, 3, 4, 5, 6, 7. I need groups of 3 to come out. So instead of going further, I'm going to group up my 27s, group up my 27s, group up some x's, group up 3 more x's. So I know on the outside, I've got a 27 from these, a 27 from these. I've definitely got an x from these and an x from these. I definitely have one x left inside this one. But the 27, I don't know. I might be able to break that down. So let's see. 27 is 3 times 9. And 9 is 3 times 3. Yep, look at that. I've got another grouping to come out. So you do have to be careful that just because I group up the 27s and I still have one left over, I need to make sure that that does that break down into a triple, and it does. Okay, so all the numbers come out, but my one X is left inside. And then I've got to put this all together. I can do 27 times 27 times 3, which I don't want to do. I have a little calculator, whoops, right here. 27 times 27 times 3 is 2187. So my final answer is 2187 x squared times the cube root of x. That's my final answer. Whew. Okay, maybe take that and see if you can do the last one. Pause it and come back. I'm gonna go over it now. So this is 64a all squared, and we've got a 5th root. So this isn't gonna be quite as long. I've got 64 times 64 times a times a. I'm looking for groupings of 5, which I don't currently have. But maybe 64 is, gonna break down into some stuff that I can take out. So 64, we're gonna have 8 times 8, 8 times 8. I don't have 5 of them, so I'm gonna have to keep going. 2, 4, 2, 4, 2, 4, 2, 4. No groups of 5 yet, but I'm gonna have 2, 2, 2, 2, 2, 2. Oh wow, okay, my writing's really bad here, but I'm gonna have a lot. 1, 2, 3, 1, 2, 3, 4, 5. That's 1 to come out. Let's see, 1, 2, 3, 4, 5, okay. And then 1, 2, 3, 4, 5. Another one to come out. I got 2 2's still in there, which makes 4. I've got a squared in there. And this is a 5th root. My final answer, sorry, this is really sloppy, should be 4 times the 5th root of 4a squared. That's my final answer. Sorry, that one got a little sloppy. I ran out of room. Okay, next, operations with rational exponents. So operations means we're gonna multiply, or we're gonna add, or whatever. But in this case, we're gonna multiply. So remember the rules of multiplication? Generally, if we had like a squared times a to the 5th, that makes a to the 7th. We add exponents. Okay, so that's what we're doing here. This is our first rule if you want to write it down. It's going to apply to number 17. And then we're going to have another rule that comes in, but this is our rule that we're following that we learned in other sections. So number 17, if I'm going to multiply these together, I have 2 times 3, so 6, a. And what do I do with my a's? They're both the same base. So to put them together, I add the powers. So a is going to be raised to the 2/3 plus 4/3, which I'm going to do. 2/3 plus 4/3 is 6/3, or 6/3 reduces to 2. That's my final answer. Let's go down and do number 20 while we're at it. Okay, same kind of rule. I'm multiplying all this together. So I'm going to do the 2 times the coefficient of 1 times the 4, so 8. And then y is raised to the power of adding all these powers together. 1/4 plus 3/4 plus 3/4. So I'm going to have 8y to the 1, 2, 3, 4, 5, 6, 7/4. That would be my final answer, except in the instructions, he says, leave your answer as a fully simplified radical. Radical means a root. So not a power anymore, but a root. So then this is going to be 8, y to the 7th, 4th rooted. And can I reduce that? Yes, I can. I've got 7 y's in here. So I've got a grouping of 4. So my final answer is 8y times the 4th root of y to the 3rd. That is my simplified radical answer. You might end up going back and watching that one again because it's a little tricky. Now number 18, we have a new rule to remember to look back at. So the rule with multiplying is same bases, we add the exponents. Another rule is if I had a to the 2nd and that was raised to the 5th, I multiply exponents when they are like that. So this becomes a to the 10th. Okay, that's the other rule we learned in the previous sections, that if I have a power to a power, I multiply powers. So that affects us here. X to the 3/2 to the 1/4. This means x to the, multiply these two powers, 3/2 times 1/4. Okay, that gives us x to the 3/8. By the way, these instructions said leave your answer as a single base raised to a power. So that is it. I don't have to put it in square root form or 1/8 root form. That is it. Now look at number 21. Similar idea. Okay, this to the 1/2 means this 1/2 is getting applied to both of these things. So this is 9 to the 1/2 times x to the 8/3 times 1/2. So this is 9 to the 1/2 times x to the 8/6 when I multiply those powers together. Now this one wants my answer as a radical. So this is 9 to the 1st square rooted times this is x to the 8th 6th rooted. Actually, you know, before I do that, let me reduce this power. 8/6 is the same as 4/3. Let me do it that way. So this is x to the 4th cube rooted. We want that to be reduced if possible. Okay, square root of 9 is 3. And this can be reduced. I've got 4 x's. So groupings of 3 can come out, and the one singular x stays in. All right, whew. Last two is our third big exponent rule to remember. And that is when, let me make this a 9. Okay, when I have division, same base with powers, I subtract the powers. This becomes a to the 9 minus 2. So this becomes a to the 7th. Okay, when I have powers that are, or things that are divided with exponents, I subtract the exponents. So that's going to get us here. This becomes x to the 4/5 minus 1/5. So that is x to the 3/5. He wanted this to stay as exponent powers, so that is my final answer. Whereas number 22, same deal, subtract the exponents, so 7/2 minus 3/2. So this becomes b to the, halves. B to the 4/2, which is easy, that's b squared. Yay, that can't get reduced anymore. We don't even have a root. That's my final answer. Okay, there's a lot that went into this, so you're gonna definitely have to let me know if you want some more instruction, but I'm gonna go do the homework and I'll send that over to you. I'm also gonna do the review and send that to you because what comes next is the first quiz, and it would be probably good to get that out of the way. Okay, good luck, bye.